Good morning, all of you. Am I audible?
Yes,
Good morning,
Yes,
sir.
ma'am.
yes, ma'am. Good morning.
Okay,
Good
okay.
morning, ma'am.
Good morning. How are you all?
Yes, ma'am. Fine.
Okay, so let me share the screen. Is my screen visible to all of you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
so let me share the course handout of this subject. Okay, so as you can see, this subject code is your ME1302 and your subject is thermodynamics. Here we are having the detailed syllabus in which I am going to teach you the basic concepts like your system property, energy, thermodynamic equilibrium, work interaction, various modes of work, heat, state postulate, zeroth law of thermodynamics, temperature scale, pressure, all all these property we need to find out, and we have to study the different instrument which are used to measure this type of property. Okay, so next we are having the thermodynamic properties of the fluids. Here we will study the pure substance, phase change of the substance, and also we will study the steam table. So we will use this steam table to find out to solve the different problems related to the steam power plant or your IC engine. So then we are having the equation of the state. Also, we will study the van der Waals equation of the state. There we will study the compressibility chart. Okay, Molecular diagram. So then we will discuss the first law of thermodynamics. So here in this case, we will discuss the flow process and non-flow process, and we will solve some problem. We will also discuss the transient flow process, steady flow process. So next we will have the second law of thermodynamics. Here we will find out the entropy parameter. There we will also discuss the entropy principle. Okay, so next is the thermodynamic potential, which will relate to the Maxwell relations. Here we will study the available energy, exergy, energy. Okay, so then we will discuss the different cycle. So only we will study the basic in this case. So there are the different types of cycle, like your Carnot cycle, Rankine cycle. So mostly there are the different categories. Here you can see there is the power cycles. So power cycles will include the Rankine cycle, ideal reheat and regenerative Rankine cycles. Then we will have the gas power cycle. So this gas power cycle is mostly related to the internal combustion engine. So internal combustion engine will work with that working of the internal combustion engine can be discussed with the help of the different cycle. So those cycles are your Otto cycle, diesel cycle, dual cycle, Brayton cycle. Okay, so these are the cycle we will discuss. Last one is your refrigeration cycle. So, in case of the refrigeration system, we have to solve some problem. So, there we will use a cycle to solve the problem. So, that cycles are your vapor compression refrigeration cycle, absorption refrigeration, and gas refrigeration cycles. So, these are the details, the syllabus of your thermodynamics. And your textbook which you are going to follow is your Sengel. This one, the first textbook T1. Next one is your textbook 2, that is the Pikenak. This is the publisher is McGraw Hill Education Publisher. So this Pikenak is the standard book. You can follow this book for your thermodynamics subject. Okay. So Sengel is also very good book. If you are purchasing these two, means it is good to get the clear idea or concept of the thermodynamics. Okay, so after this textbook, other than this textbook, you can refer the reference book. So reference books are your some tag. Okay, so that book name is Fundamentals of Thermodynamics, which is the Wiley publication. Then we will use the data book. All you need to purchase this data book that I have already told you, steam tables. So in case of the steam tables, you will also find the Mollier chart. Backside of that steam table, Mollier chart will be available. Okay. So the data book for the steam table is your, the author is K.K. Ramalingam. So that should be SI units. You have to check it whether it is the SI unit or not. So all of you have to purchase this SI unit book. Okay. So after this textbook, you can also mm, search the internet and you can go through this website NPTEL. So there you will get also the knowledge of some thermodynamics. Okay. So here it is my lecture plan. So I will cover the all the mm, um, like this lecture number 1 to 2 is your here I will teach you the basic thermodynamics, so which will include the state and properties of the system, and also it will include the process of the system. Okay, so this one I will provide to you, this you will share to all of you. Fine. So all of you know this evaluation scheme, I think, because already you have given your exam. Okay. So if you have any doubt, please feel free to contact me. You can contact me over my phone, or you can mail me. Okay. So this is your course handout. So now we will discuss the basic concept of your thermodynamics. As the subject name is thermodynamics, means all of you have some knowledge in this field, basic knowledge, I think. So thermo thermodynamics means it is the word derived from the Greek word, that is your therm. Another one is the dynamics. Okay, so therm meaning is your heat, dynamics meaning is your power. So from this definition or categories, we can say that thermodynamics is the science of energy. So heat is your one form of the energy. So thermodynamics is the science of energy and its transformation. Okay. Also, the effects of this energy on the substance, on the quantity of the substance. So mainly thermodynamics is the science of energy. Okay, and its transformation. So there we will discuss the 3E. So what is the meaning of 3E? 3E means that is your energy, equilibrium, and entropy, right? So all of you have idea about this energy. So energy, there are different forms of energy in this world. So energy, maybe it is the internal energy, potential energy, kinetic energy, right? Kinetic energy. Then we are having the nuclear energy, mechanical energy, and then we will have your wind energy. The list goes on like this. Okay, so there is the different forms of the energy in the world. So then we will have the equilibrium. So it is the main thing which we are going to discuss in thermodynamics. So equilibrium means perhaps all of you have studied in Zero's law of thermodynamics. Okay, so equilibrium means there we should not have any extra forces or any unbalanced forces which are present in the any system. So equilibrium means all are in constant. Okay, so next entropy is nothing but it is the degree of randomness. Okay, disorderness. We can say when entropy is increasing, in disorderness increasing. So here entropy is main thing we are discussing in thermodynamics. So there we will discuss the irreversibility of the process. So we will discuss in subsequent chapters. Okay, so next one is the all of you have know that practical application of the thermodynamics. So in our day-to-day life, we are applying this thermodynamics to solve our problem. So the mainly practical observations which are exist in our day-to-day life. These can be converted into the thermodynamic laws. Okay, there we are having the different principle also. Okay, thermodynamic principle, thermodynamic laws. Okay, so these thermodynamics are applicable to the different sectors. Mainly, these are if we are writing the application, these are application to the different sector. So mainly we are using these thermodynamic laws or thermodynamic principle to solve the problem in a steam and power plant, right? So what are the other example? Also we are using it IC engines. IC engines means it is the internal combustion engines. Here steam engine is your external combustion engine. Okay, so mainly we are applying to the heat engine. Also we are applying to the gas turbine and your refrigeration and air system conditioning system. Okay, so there we are having the different laws and principle. So first one is the conservation energy principle. So what is the meaning, what is the conservation of energy principle? I think all of you have this idea. Conservation of energy principle means the energy cannot be created or destroyed. So always it will be the in balance situation. Suppose any system is having some energy input and it is having some energy output. So in that case, the energy change can be defined in the form of this is the energy change is equal to the E in minus E out. So if you will see in this equation, there is the energy balance. So the both the energy which is entering and leaving to the system from the system will be equalized and that is conserved. So this is the conservation of energy principle. So this conservation of energy principle we are also we are applying in many problems to solve the our practical issues. So this conservation of energy principle, if you are applying in case of the um, nozzle, diffuser, turbine, or your compressor, then there we will have work output or input. We will, can find out this from this relation. So this is a conservation of energy principle. So what are the laws which we are discussing in thermodynamics? That is the first law of thermodynamics, second law of thermodynamics, and then we are having the zeroth law of um, thermodynamics. Okay, so what is first law? So first law is it will describe the conservation of energy principle. Also, it defines that energy is the thermodynamic property. So it will find one property that is your energy. So that is your first law, and second law is your second law. It will define the quantity as well quality of the energy. Okay, so it will define the quantity and quality of energy. Also, uh, also it defines the direction of actual process. So what is the meaning of it? So if you you can see that this is the first law. So it will define the conservation of energy principle. That means it here in this case, what is the quantity of energy is going in and out, that will be described in this case. Also here we will find a new term, that is the energy, internal energy. So which is the thermodynamic property of the system. Okay, but in case of the second law, not only the energy will be quantified here, we can also know the quality of the energy. So quality of the energy means there is the low grade energy and high grade energy, right? So all of you know that low grade energy or high grade energy means there is a two kind of energy. One is the heat and work. Okay, so high grade energy means here the quality of energy is good. So mainly heat is the high grade energy we are considering. So the flow of heat is always in the decreasing temperature, right? So that's what here it is mentioned. It will quantify it as well as it will define the quality of the energy. So the process, whether it is the reversible process or irreversible process, here we can know about that reversible process and irreversible process, and also there will be the flow of the process at particular direction that can be known from this second law of the thermodynamics. Then we are having the zeroth law of thermodynamics.
Hello, ma'am.
Yes, please.
Ma'am, can you please elaborate once again low grade and high grade energy?
So low grade, that is defined as the quality of energy. Okay. So quality of energy means it is capability of converting the energy one form to another. Okay, so low grade energy mostly we are saying that it is the work, and high grade energy means it is the heat. So heat means in that case we can say that the maximum amount of energy is transferred to the useful energy. Okay, so that's why the name is given high grade energy. Okay, so I will discuss it in second law of thermodynamics. So properly I will discuss. So there we are taking some example. So suppose um, compressor is there, right? So compressor or turbine. So let us take the example of turbine. So there steam with the high temperature and pressure it is entering to the turbine blades. Okay, so that high velocity, high pressure energy will be converted into the kinetic energy, which will rotate the wheel of the turbine, and that will convert it into the work. Okay, so that's use of steam, high pressure use of steam, and uh, temperature of the steam will give you the maximum work output compared to the low grade energy. So I will discuss in the next chapter. So there I will discuss both heat and work. Okay. Okay, these two points I will
And what
discuss.
is the example of low grade energy?
Low grade energy, mainly we are considering the work. These are the two forms of energy. One is the heat, another one is the work. So I will discuss it. Don't worry. So zeroth law of thermodynamics means it will defines the term that is your temperature. So the law defines that if two bodies are in thermal equilibrium, no need to write, I think I will give you the example. Okay. So A, B, C, it is a common example. All of you have this idea. So if A, B both are in thermal equilibrium with C, then these two body will also in thermal equilibrium with each other. Okay. So that is your zeroth law of thermodynamics. It will give the definition of the temperature. Okay. So that will also I will discuss. There is the different temperature scale. I will discuss that one, and we will also solve some problem related to this. Okay. So next one is your systems, which is also known as your thermodynamics system. So thermodynamic system means it is the certain quantity of matter as well as region of space which we are considering to solve the particular problem. That is known as your thermodynamic system. Okay, so if you are observing here, this one is your system. Okay, okay, so it is certain quantity of matter or it is the region of space in the system. So which we are considering for our engineering problem to solve a certain problem. So that is known as your thermodynamic system. So outside of the system is known as your surrounding. Okay, so this system and surrounding both will be separated by the boundary. Okay, so this boundary may be the real or it may be the imaginary one. Okay, so it may be the fixed type or it may be the movable type. Can you give some example of this one if anyone is having any knowledge about this?
Piston is movable and a wall is fixed.
Okay, piston is movable and wall is fixed. Okay, then. No, you give some example like it is the piston cylinder arrangement. So inside this one we are keeping certain quantity of matter. Suppose there is the energy transfer. That means heat is given to the system. So what will happen? So it will expand. So here in this case it is the movable one, right? So where we can consider the fixed boundary? In the
Thermos
example.
flask. Thermos
Okay,
flask.
thermoflax. Okay, good. So these are your this one is your boundary which we have considered. So next we are having the closed system. So in case of the thermodynamic system, we are having the closed system. So all of you have this idea. As one of you have given this example, piston cylinder arrangement. So closed system means in this case we are having the certain quantity of matter which is fixed. Okay, so in this case, mass is fixed, right? So this closed system is also known as your control mass, right? It is also known as your control mass. Control mass means in this case your mass is fixed. So in this case we are having the fixed or movable type of your boundary. So here in this case it will be having a real boundary. Okay, so closed system means here your quantity of mass is fixed but energy is flowing to or out from the system, right? So what I mean to say, if it is the piston cylinder arrangement, here we have taken the certain quantity of matter. Suppose it is your gas. So in this case, we can say that in this case, quantity of mass is fixed. M is fixed. So this mass will never flow out from the system, and the amount of mass is fixed in this case. That means there is no mass transformation transfer. Okay, so no mass transfer. That means there is no mass in and mass out from the system, but there will be the energy transfer. So energy transfer means that energy will transfer in the terms of the heat or it will transfer in the terms of the work. Okay, so there will be the energy interaction. Okay, so heat means where you can give some heat input to the system, so volume will expand. So in this case, your volume is not fixed, right? So how will you give that energy transfer through the work? So here you can include any paddle wheel work or any means it is your paddle wheel work means you are putting some it is your wheel or here it is your weight some you are putting some weight. Also this can be given through the software. So suppose we are considering the compressor. So suppose it is driven by the motor, then we are giving we are considering as it is as your work transfers through the motor, that is the shaft. Okay. So this is your closed system. This closed system is also known as your control mass. Next one is your open system. So open system means here your mass as well as energy interaction will be there. Okay, so in case of the open system, we are considering the certain, suppose it is the pipe, it is inlet, it is the outlet. Okay, so here suppose you want to solve some problem, so you want to find out your velocity or your flow velocity, or you want to find out what is the pressure outlet. So in that case, you have to consider certain region of space. Okay, so this is the certain region of space that is known as your control volume. The boundary of this control volume is known as your control surface. So this one is the control volume, this one is the control surface. So here, in this case, both mass and energy interaction will be there. So in this case, we are considering the different process, that is a steady flow process, or transient process. Okay. So steady flow process means here we are considering that the whatever the amount of flow is entering and leaving from the system, that is constant. But in this case, that flow of energy and mass will vary with the time. Okay, so these two processes we are considering to solve the problem in case of the open system. This open system is also known as the control volume system. Okay, so in case of this closed system or control mass system, here we are considering the special case that is known as your isolated system. Isolated system means the system in which there is no mass transfer as well as the energy transfer. That is known as your isolated system. So one of
Ma'am, it is a different case or it comes under closed system only, like isolated
it
system.
generally we are telling us it is a special case of the closed system. As one of your friend has discussed, told na, that thermoflax. So thermoflax is one example of this isolated system. Okay. So in which there is no mass transfer as well as there is no energy transfer. Okay. So this isolated system is generally we are considering the special case of closed system. Okay. So next, this one already I have discussed to you. This is a control volume and control surface, right? So then we will have the properties of the system. So properties of the system means it is the characteristics of the system. Okay. So suppose if we want to find out the characteristics of the any system, that can be find out with the help of the properties of the system. So there are the basic properties of the system. So those are your temperature, pressure, and specific volume. So these are the basic properties of the system. After that, we are having the other properties there, like your specific energy, E, or energy, like that. Okay. So then we are having your density is also one property. Then we are having the your thermal coefficient of expansion. So other properties like your what you can say specific volume we have already, the specific energy already we have discussed. So there are the many more properties of the system which will which can define the characteristic of the system. Means any uh, suppose you want to say that during the solving of the problem these properties we are considering. Okay, so then we are having the different categories of properties. One is your intensive properties, another one is the extensive properties, right? So intensive properties means it will not depend upon the mass, but extensive property means it will depend upon the mass. Okay, so intensive properties are your temperature, pressure, these are the example, and density. Extensive properties means it is your specific volume, okay, and your specific energy, specific enthalpy. So these are your example of your extensive properties. Okay, okay. So next one is your state. Okay, state. Can you define? Any one of you? What is the state of the system? Any one of you?
The variables which describes the states of a substance is known as thermodynamic state variables.
Please repeat. Ayush Agarwal, right?
Yes, ma'am. The variables which describes the state of a substance are known as state variables or
No,
thermodynamic
I'm
state.
not asking you the state variable. I'm asking you the word state means what?
State of a
Sir,
system.
ma'am, like a physical condition in which an
Right.
matter is.
Okay. Krishna Kumar, right? Okay. Thank you.
Yes, ma'am.
So it will define the physical condition of any system. So that is known as your state. Okay. So there are having the different state, right? Solid state, liquid state, and vapor state. Okay, so solid state means it is the one condition of the system in which the mixture, there is no presence of any mixture. So in that case, that molecule will closely packed. Okay, right? So that is known as a solid state. And then we are having a liquid state. Liquid state means in this case, your molecule will loosely packed. And next one is the vapor state. Sometimes we can say that it is a vapor phase. Phase is different one. So vapor state means there it is the mixture of molecules. So that may be the condition of the state may be the two-phase system. Okay. So mainly we are discussing the solid and liquid state. So it will define the state of the system, and this state of the system will be defined by the properties of the system, temperature, pressure के हिसाब से वो आपका कंडीशन के हिसाब से आप उसका प्रॉपर्टीज फाइंड आउट कर सकते हैं बाकी प्रॉपर्टीज एंड यू कैन सॉल्व द प्रॉब्लम ओके. So that is your state of the system. So tomorrow we will discuss. Now I'll take your attendance. Okay, Ayus,
Present, ma'am.
Ayan,
Present, ma'am.
roll number 3,
Present, ma'am.
4, Priyansu, 5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12, 12, 13,
Present, ma'am.
14,
Present, ma'am.
12 is absent, right? 12, 13, 14, then 15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19, 20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
23,
Present, ma'am.
24, 24, 25, 26,
Present, ma'am.
27, 26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37, 37, 38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43,
Present, ma'am.
44, 45,
Present, ma'am.
48,
Present, ma'am.
49, 49, 46, 47 एब्सेंट है क्या? वो यहाँ अच्छा अच्छा 49, 50, 51,
Present, ma'am.
52, 53,
Present, ma'am.
54,
Present, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58, 58, 59, 59, 60,
60 present, ma'am.
61,
61 present, ma'am.
62,
62 present, ma'am.
63,
Present, ma'am.
64,
Present, ma'am.
65,
Present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
68,
Present, ma'am.
69,
69, present, ma'am.
70,
Present, ma'am.
71, 71, 72,
Present, ma'am.
73,
Present, ma'am.
74,
Present, ma'am.
75,
Present, ma'am.
76,
76 present, ma'am.
77, 77, 78,
Present, ma'am.
79,
Present, ma'am.
80,
Present, ma'am.
81,
Present, ma'am.
82,
Present, ma'am.
84,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Present, ma'am.
88,
Present, ma'am.
89,
Present, ma'am.
90,
Yes, ma'am.
91,
Present, ma'am.
92,
Present, ma'am.
93,
Present, ma'am.
94,
Present, ma'am.
95, 97, 98, 97 and 98, 99,
Present, ma'am.
100,
Present, ma'am.
101, 101, 102,
Present, ma'am.
103, 103,
Present, ma'am.
104,
Present, ma'am.
105,
Present, ma'am.
106,
Present, ma'am.
107, 107, 108, 109,
Present, ma'am.
110,
Ma'am, 100 is present.
Present, ma'am. 110%.
108 present. Okay,
Yes, ma'am.
110,
Present,
110,
ma'am.
111,
Present, ma'am.
Yes, ma'am.
112,
112 present, ma'am.
113,
Present, ma'am.
114,
Present, ma'am.
115, 115, 116,
Present, ma'am.
117.
Excuse me, ma'am.
Ma'am,
Yes, please.
77 present.
Ma'am, 107. Mic was not working.
Okay.
Ma'am, 77 also.
Why you people have joined late?
Ma'am, I was joined, but mic wasn't working. I wrote in the chat box also.
Okay, fine. So tomorrow you will have your class from 8 a.m., right? So are you all comfortable with that time?
Ma'am,
Yes or no?
8:30 onwards will be
No,
better.
no, no. 8 only, ma'am.
Okay. Okay. Okay, then fine. 8 o'clock is better. One thing I want to ask you whether that Cisco VVS is working or not. We got the mail from Din Academy and that we have to take the class in Cisco VVS. But for me, it is not working. So all of you have checked.
No, for us also not working. Google Meet
And
is
that
good.
disco is not good,
Yes,
ma'am.
legend
It's
that
very
does.
irritating, that sound.
So yeah, right. I was trying from 10 a.m. I thought that I will be ready, but I could not join in that link. So tomorrow also we will continue through Google Meet. So I will ask to Teen Academic if it is possible. Uh, I will take through this Google Meet only. Okay. Okay. Thank you all. So tomorrow onwards, in between the class, I will give you some question. I will give you one question like that, and you have to fill that Google form and submit. I will give you the time of 2 minutes. Okay. So not regularly. Often I will give you like that. Okay. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, Shekhar.